In lecture 22 we will discuss the inverse S transform method, which is known as a partial fraction expansion method. All other methods we discussed in the previous lectures. From lecture 18 onwards we are discussing the inverse transform, and before attempting the partial fraction, that is lecture 22, please watch lecture 21, which deals with the table of S transform pairs. Okay, and after that you can watch the partial fraction expansion method. Now we will see what I mean by partial fraction method, and with one example we will see what is partial fraction method. Okay, in order to attempt partial fraction method we need some transforms. So here you can see a question, find the inverse S transform of x of z, and x of z given by 1 by 4 z raised to minus 1 divided by 1 minus 1 by 2 z raised to minus 1 into 1 minus 1 by 4 z raised to minus 1. And here the ROC of the signal x of z is given by modulus of z greater than 1 by 2. Okay, now we can find the inverse S transform. So for that, first we need to factorize this equation. So you can write x of z. Okay, first we need to make this equation into positive terms. So in order to make it in the positive factors, we can multiply with z square. Okay, so if you multiply it with z square, z is into z here, and the denominator also we need to multiply with z into z. Okay, so here one z is multiplied with one factor and another z is multiplied with another factor. So after that you will get, it becomes 1 by 4 z divided by z minus 1 by 2 into z minus 1 by 4. Okay, and now the z powers are in positive, and now we need to perform the partial fraction. So before performing the partial fraction, always remember that so there is an z, the numerator, bring that z to left side. Okay, so always do this option. Okay, write like this: x of z, sorry, it becomes x of z by z. Okay, perform the partial fraction on this expression x of z by z, then you will get the remaining term 1 by 4 z minus 1 by 2 into z minus 1 by 4. And now we can split this into a by z minus 1 by 2, okay, plus b by z minus 1 by 4. Okay, this is known as a partial fraction. Okay, now we can equate the numerator and denominator. For that I can cross multiply this, so it becomes a into z minus 1 by 4 plus b into z minus 1 by 2, and the denominator becomes z minus 1 by 2 into z minus 1 by 4. And you can see that these two equations are same. Okay, so the denominator you can denominator is same, so you can equate the numerator part. So if you equate the numerator, it becomes 1 by 4 is equal to a into z minus 1 by 4 plus b into z minus 1 by 2. Okay, and when you substitute z is equal to 1 by 4, this term becomes 0, and remaining you can write 1 by 4 here, b into 1 by 4 minus 1 by 2. So from this you can write b is equal to minus 1. And similarly, if you substitute z is equal to 1 by 2, the second term is equal to 0. So here you will get a into 1 by 2 minus 1 by 4. So based on that you can write a is equal to 1. So we got the values of a and b. Now we can substitute. So x of z by z is equal to 1 by z minus 1 by 2 minus 1 by z minus 1 by 4. Now we can multiply this z to the right side. Okay. Now we can rearrange this equation like this. X of z becomes z by z minus 1 by 2 minus z by z minus 1 by 4. Okay. Now we can compare with the standard form, and before that, so there is one term z by z minus 1 by 2. Okay, and now we need to find the inverse of this. So you can see that this is in the form z by z minus a. So there are two options, either in the causal form or in the anti-causal form. That depends on this ROC. So we need to evaluate the ROC now. So here the ROC is given modulus of z greater than 1 by 2. Okay, ROC is modulus of z greater than 1 by 2, and here we will get two poles. One is z is equal to 1 by 2 and one is z is equal to 1 by 4. So in the graph I can indicate, assume that this is the pole. So one pole at z is equal to 1 by 4 and another pole at z is equal to 1 by 2. Okay. So based on this you can see the ROC is modulus of z greater than 1 by 2. So this is the ROC, and in this ROC region you can see that 1 by 4 represents the causal part, and this 1 by 2 also representing causal. Okay, from the standard definition, if the ROC is greater than the poles, these two poles represent ROC. So we can write the answer in a causal form. So I can write x of n is equal to, this you can write 1 by 2 the whole raised to n into u of n minus 1 by 4 the whole raised to n into u of n. Okay, so this is the answer.